Hey guys, in this video, we are going to just kind of get the basic notes for ellipses, but before we really get into that heavy topic, we're just going to kind of briefly discuss circles. Circles are a special type of ellipse. So if you recall back to when we first started talking about conics, if you were to take one of those double-naped cones and cut it horizontally, just straight across, that's when you end up with a circle. However, if it's tilted just slightly, it ends up being elongated and we see what's called an ellipse. Okay, so they're very similar in nature, but because they have a very similar structure. But one is elongated and one is just perfectly round. And so the circle is the set of all points in a plane that are equidistant from a fixed point that's called the center. Now, you guys would have learned about circles back in geometry and you would have studied quite a bit about them. So we're not going to spend a ton of time on this. We're just going to kind of briefly remember what a few different parts of the equation of a circle are, just to say that we've been able to touch on that subject again, but you have seen this equation and you did study it a couple of years ago back in geometry. The equation for a circle, as you can see right here, that has a center at hk, it would be x minus h squared plus y minus k squared, and that's equal to the radius r squared. Okay, and so it's pretty like easy to graph from that if you have to. You just would plot the center and then you would go out whatever the radius is, left, right, up, and down, and then connect it as a circle. It's pretty easy to graph them if you needed to. So this example that we have is it just says to describe the transformations on the unit circle. So this is a little bit of a different question than what you guys would have seen back in geometry because you wouldn't have known what the unit circle was. If you remember, we've discussed that pretty much at length. You got to remember what the details were, though. The definition of the unit circle was that it had a radius of 1. So, and the center was at 0, 0. So to know what the unit circle was, I'm just going to put like a little bit of a reminder as to what that was so that when you're trying to understand what you're talking about here, just remember. So here's our little reminder. The unit circle is just x squared plus y squared equals 1. So we're trying to think of what are the transformations that have occurred from the unit circle. Okay, and so what you're seeing here with this center at the unit circle, the center was at the origin. That's why you don't see anything added to the x or added to the y. But if we have this different circle where the center is at negative 2.5 and positive 11, right, then that center has been translated. It's been shifted both to the left and up. So when we talk about the transformations, really we need to see what is that center. Also, our unit circle had a radius of 1. This guy does not. So I can use that value to help me decide how the circle has been dilated. Okay, so because again, the radius is just talking about how big is that circle. Well, this is going to be a bigger circle because the radius squared is 8. So we'll be able to see how it's been dilated. Now, don't fall into a trap saying that it's been dilated by a factor of 8. That's not true, okay? Because the radius squared is 8, okay? Not the radius. So we're going to have to try to figure out exactly what that is. So in order to tell the transformations, it's going to be a whole lot easier if we first figure out what is the center and what is the radius. So the center is the easiest. You just look, what's h, what's k, you get your point. We're always going to use the opposite sign. So my h is going to be a negative 2.5. And my k is going to be a positive 11. Okay. The other thing we needed again was that radius. Now, we know that the radius squared is 8. So if I want to know what my radius actually is, square root that, and you can simplify it. Don't bother giving me a decimal. I don't like those. I like to see the exact answers. So this right here is enough work to show me what's going on, and then we can see what our transformations are from that. So we should be able to see, because our center is at negative 2.511, our transformations are that it shifted, or translate, right? That's the fancy word for it. So we have that it shifted to the left 2.5 and up 11, just from seeing that center. And then my radius is 2 square root 2. Think about the fact that the radius on your unit circle was 1. So what's the factor it's been dilated? 2 square root 2. Okay, so we're going to say that there is also a dilation of just 2 root 2. And then that's good for giving the transformations. Ta-da! All right, that's pretty much the only example we're going to do in this video. The rest of this, for just this video, is going to be just getting notes on ellipses. And then we will go through quite a few more examples in the next video. I'm just trying to think of like how this is going to break up when we're actually in class. And my thought is it's going to take a little bit of time to get these notes, just like it did with the parabolas. So let's switch over to that. Let's look at ellipses, okay? Now, ellipses, they are elongated, so you're going to see this type of shape. I'm not a great artist, but I would get just a rough sketch of what this is on your own notes so that you have that as just a little reference. An ellipse, it is the set of all points on a plane whose distance is from two fixed points called the foci. That's the plural for focus. They have a constant sum. Okay. It causes us to have this little ovally type shape. Now, just to kind of get our little definitions for all the different attributes or things about this, right? You've got the focal axis. That's the line that goes through the foci. So if I've got a horizontal ellipse like this, your focal axis would be horizontal, but I could have this flipped and going tall ways vertically, right? And that the line would go that way. So it just kind of depends on which way the ellipse is going. Your center, that is the point that is halfway between the foci. It's also halfway between the vertices, so that's fun. The vertices are the points where the ellipse intercepts its axis. So you're seeing that over here on either side over there. And then we have two different axes that we're going to like kind of study here. Not just the focal axis, but if we're talking about like the major axis or the minor axis, we're looking at the little segment or the chord. Okay, the chord, if you remember that term from back in geometry when you dealt with circles, it just talked about a segment that was inside the circle and it hit two sides of it. So that's what we're seeing here, or just think of it as a segment. And it's the major axis goes between the vertices, so that's going to be going long ways like this. But you notice how it's only inside the ellipse. We don't see that extending outside, okay? The length of that is what we're going to call 2a. So this a value is going to be a pretty important value when we're dealing with ellipses, and you'll see that a little bit more in a minute. A is always going to be the bigger value. B is a little bit smaller because that's coming from our minor axis. Our minor axis is the segment that is going to be perpendicular. Is actually, I would say, a perpendicular bisector. It's going to cut this guy in half. But yeah, so it's going to cut through here perpendicular to that focal axis or to that major axis and going through the center, okay? The length of this one is 2b, but that's going to be shorter than the major axis, okay? So the a value is going to be more than the b value, and that's an important piece to remember. Now, C is going to talk about this distance from the center to the focus. So if I equate that back here, you'd be going from the center to the focus. Okay, now I could draw like 1,000 different pictures to try to give you like all the different ways that this is kind of structured. But if you were to like try to view there being a little like little triangles and stuff like that, you could. It's just a little tricky to place all of that. This right here comes from the Pythagorean theorem, but I want you to see that it is structured differently than the Pythagorean theorem was structured. Okay, C is talking about the distance from the center to a focus, and we get this relationship that a squared equals b squared plus c squared. Okay, now our textbook has a nice little pretty picture of that in this section. So if you want to see a little bit more details about that, I just didn't think I didn't think we had enough needed to really stress about getting it all in our notes. But our textbook does have some really pretty pictures about how this relationship really is structured. So feel free to check that out in this section 6.4. But yes, this is a little different than our normal Pythagorean theorem because the A in this circumstance ends up being the like hypotenuse for the way that it's structured. Okay, that brings me to all of our lovely little formulas and our little foldable that we're going to have in this section. So here we have our beautiful little foldable. You'll get this from me in class if you haven't already, right? And we're just going to fill in one side where the center is at 0, 0. What is our relationship? So I want you to think about what happened with our circles. Our circles, we had our x value was being squared and our y value is being squared. It was equal to this radius squared. Here's the deal. We had this like equal distance from the center. That's what the radius was that there was this equal distance from the center to the circle at all times, right? That's the whole point of what a radius is and the definition of a circle. We have this structure where both x and y are both being squared and they're being separated by a plus sign. That's going to stay consistent, okay? But you're going to see that we don't necessarily have a radius, okay? Do you notice how these values on the circle, they're not being multiplied or divided by any kind of value? So it's not going to like stretch that specific section of your circle. I know that sounds a little weird, but the way that the ellipse works is you're going to end up having these more fractional type of relationships, okay, where you're going to see that if our center is at 0, 0, right, we don't have to worry about the h and the k business, but you are going to see that these values, the x and the y squared, we're going to be dividing them by an a squared and a b squared. And in doing that, it causes us to have that different, like it elongates along one axis and shortens along another. In standard form, we have it set up to where it's equal to 1. So if it's not equal to 1 like this, then it's not in standard form. Another important thing to note is look at the difference between whether it's on the horizontal axis versus the vertical. The only thing is that your x's and y's were swapped. Okay, how does that change anything? Well, remember that the a value was supposed to be the larger piece from up here. That was from your major axis. That's from the longer segment. And so for that, when I'm seeing the way that this is structured, notice how the larger that a value squared, that is underneath x. And then the smaller one is underneath the y. When that changes and my larger one is underneath the y, that causes us to be elongated vertically. Okay, so instead of it looking like this, where it's horizontal, it's going to be like flipped and it would be tall ways. Okay, that's what I mean by like the vertical axis. And that's if the larger value is underneath the y squared. So in standard form, we're going to have that larger denominator written first and then the smaller one second. Okay. Okay, if your center is at 0, 0, then your focal axis on the horizontal is just on the x-axis. On the vertical, it's on the y-axis. Our foci, because remember we have two of these focus points, right? And so plural, we call them foci. But the way that we find them is we just look at both the positive and the negative. So we get 2 points. We're going to get positive C0 and then negative C0. So you're going to get 2 different points. And then if we look at foci for the vertical axis, that's just swapped. So it's 0 and then plus or minus C. Your vertices, okay, remember what we said, the way that this is structured, your major axis, that's this guy going through here. So from the center to a vertex is half of 2a, which is just a. Okay, so here this would be 1a. So if you're looking for the vertices, you're looking at plus or minus a, 0, or 0 plus or minus a, depending on the way that this thing is turned. We have 2 more terms here that I just kind of let be in this instead of writing them out separately. And it's just looking at what is A, what is B. The semi-major axis, so not the major axis, but the semi-major axis is only half of that major axis. So that's what A is. And the semi-minor is just half of the minor. So instead of 2B, we got B. That's just trying to give you a good definition of what A and B are. Okay, but what if the center is not at 0, 0? If the center is not at 0, 0 and it's at that HK, I want you to remember what we had with circles, because this is going to be a similar structure. You're still going to have this situation where you have x minus h all squared, and this y minus k all squared, and things are going to be separated with a plus sign. However, we're going to see a fraction in my standard form. So here's what we have with my center at HK. Again, you're seeing this x minus h all squared, y minus k all squared. They're separated with a plus sign, but just like on the center at 0, 0, we're going to be seeing these as over a squared or over b squared. And we have the same rule that applies. Whatever the larger denominator is, that's what needs to be written first. Okay, and that'll help you to kind of keep track. Are we working with a horizontal axis or a vertical axis? You can see your focal axes here. You can see your foci, which are a little bit more complex. You just take your center. But do you remember how back here we would have had just plus or minus C, 0? This is H plus or minus C, K. So you think about the fact that the last one had just been at 0, 0. If I plugged in a 0 and a 0, it would be plus or minus C and 0. Right? So this is the same thing. It's just we're plugging in the H and the K, so it looks a little bit funkier. Vertices, H plus or minus A and K. So again, it's very similar to how we got the vertices on the last thing. It's just that we're not at 0, 0 for the center. Anyways, those are your formulas. In the next video, we are going to talk about applying them all and being able to work out problems. So definitely make sure that you stay tuned for that if you miss class, and I will see y'all in the next video. Bye.